So I also want to talk a little bit about the second midterm. So this is the example from test number 2, question 1, which is our two-period intertemporal choice model. And the equations that we're given look like this. So we're given that savings is whatever you don't spend in the first period, but then consumption in period 2 depends on whether you're a saver or not. In both cases, you're paying interest, but in case 1, it's what we're used to. In case 2, it's not quite what we're used to. And so we've got a kink, for lack of a better word, even though it's not really a kink, based on whether or not you're a saver. So this F, why is that happening? This F is what I called a savings fee. So in this model, you've got a fee, this charge, to open a savings account, basically. The bank doesn't want to do business with you unless you pay with them something. And you might think, well, how is that going to look in two-period intertemporal choice world? Well, the easiest way is to just work with the equations a bit and sub them in, right? If I think of when I'm borrowing, right, I get C2 equals 1 plus R, Y1 minus C1 plus Y2. DC2, DC1 is minus 1 plus R. If savings is greater than 0, C2 is equal to 1 plus R, Y1 minus C1 minus F plus Y2. And DC2, DC1 is still equal to minus 1 plus R. And so we're saying, aha, of course the slope's not going to change. Regardless of whether we're a saver or a borrower, we're still facing the same constant slope. Why are we still facing the same constant slope? Well, because the savings fee is a fixed amount. It doesn't change the trade-off at the margin. It's a lump sum, right? Lump sums don't change slopes. They shift lines up and down. If you wanted something to change the slope, it's got to be on a per unit basis, right? Because the slope is telling you something about the trade-off between C1 and C2. Here, there's no ongoing trade-off at C1 and C2, right? If we're saving $3 versus $1,000 versus $15 million, we're still paying the same F, and so there's no change in the margin, which we can see if we're willing to do just a little bit of calculus, right? So when you come up against these two-period choice problems and you're not sure about how to sketch the diagram, it's maybe always worthwhile thinking just a little bit about, well, I can just take a really easy derivative and clarify any problems I might be having here.